my name is Kingsley Kefas, and I'm a software engineer and blockchain developer at Blockfish Labs. I'll be your tutor for today. So here's my Twitter handle, OX KingKC. Yeah, you can actually reach out to me at any point in time there. Even though, yeah, I don't post much on Twitter, but yeah, I'm active. Right, so today's agenda, basically what we'll be doing today is talking about what blockchain is, the little components of blockchain, life cycle of transactions, talk about blocks and transactions. We'll see how blockchain works. We'll see the use cases of blockchain, basically the applications you can build on blockchain. And also, yeah, the challenges and limitations of blockchains with the solution we currently have, right? So before I go further, who can just briefly tell us what he or she understands by blockchain, like what a blockchain is? Joshua, tell us what you understand by blockchain. I think Joshua permits me, I might not pronounce it well, Uteno.
Okay. GM everyone.
Yeah, GM.
GM was okay. To me, blockchain is a series of, I think, decentralized ledgers. I think that's what it is. It's a ledger basically.
Okay. Yeah, you said decentralized ledger. Okay, so
Yes.
yeah, any other person? Sati, what do you understand by blockchain?
Okay, so maybe breaking it down to the simplest or the clearest, we can just simply say it's a interconnection of systems that work together to achieve a unified outcome or a unified result.
Okay. Connection of systems to okay. Fair enough. Clement, yeah, you were about to say something.
Okay, so according to my own understanding, let me just say it's a digital system that helps us store data and information in a secure and transparent manner. And also it's also unchangeable.
Unchangeable. Unchangeable. No, I wouldn't use that word, but yeah. So yeah, I believe you all have tried. Yes, you all have made attempts and then tried. So yeah. So basically let's see what a blockchain is and then try to understand it better, right? So what is a blockchain? That's the big question. Now, most people, when you talk about blockchain, I mean, yeah, what they see is, or what they envision is airdrop, right? They begin to think of things like tap swap, hamster combat, and the rest. But blockchain is not even that. It's basically far from that, right? So this is the definition of a blockchain. What's a blockchain, right? So a blockchain is basically a decentralized, distributed, and immutable ledger that records transactions across multiple computers, across various computers, right? So while you guys were defining blockchain, I believe some of you mentioned some keywords, some major keywords. But yeah, when defining blockchain, the major keywords you need to include is decentralized, right? We know that yes, Web3 is all about decentralization. The blockchain is all about decentralization. And then what is decentralization? Meaning that everything is not, should I say, controlled by one person, right? Everything is not controlled by what? One person. Decentralized. Basically, everybody has his or her own control of his or her own data per se. So blockchain is all about decentralization, one. Now, the second keyword you need to actually keep in mind is also distributed, right? When we say something is distributed, it means it is scattered. Not scattered anyhow, but then yeah, like scattered across different locations or different places. Now in blockchain, basically it means every information is being scattered across different computers, right? And all those computers are not being controlled by one person. So you can see the intersection of decentralization and distribution in this case. Now, another keyword is immutable, right? Immutable. Now, what does immutability means? Immutability basically means you not being able to actually alter that data, right? Basically, once the data is there, it is there. Yes, even if, let's say, for instance, you are updating the state of the data or updating that data, the previous record will still be there. So what you are doing is you are not changing that particular data, should I say entirely. What you are doing is you are just creating a new state, but then the previous data is still there. So that is the immutability of blockchain. You can't delete that data, it's there, right? Everybody can see it, it's publicly available for everyone to see. And then another keyword is ledger, right? So most times if you ask me what's the definition of blockchain, they'll tell you that a blockchain is what? A public ledger. Yeah, they are not wrong. It's a public ledger because we all know that a ledger is just basically I mean, in the normal definition of a ledger is just basically a book that keeps what record of transactions or records of activities, basically. But then in the case of blockchain, the ledger here is basically meaning the database, right, that contains all the data in that blockchain. And since we said the blockchain is centralized and distributed, it means that for every record, right, for every transaction that is being recorded on the ledger, now all those separate computers that are participating in that particular blockchain or in that particular network will have what? The same record. They will all have the same copy of the record. Anybody having a separate copy basically means the person is trying to do what? Trying to gain the network. The person is trying to poison the network. Let me put it that way. Yeah, so I don't know, any question? You people should ask your questions or I ask questions.
Okay. Sorry.
Yeah.
Okay, I want to ask you a question.
Okay.
Sorry, please can you go over? I didn't really understand what you meant by poisoning the network.
Okay. All right. So let me repeat that. What I meant or what I meant by poisoning the network is, let's say for instance you have, let me use an analogy now. Let's say for instance you all have a record of attendance, maybe in your classrooms, right? You have a record of attendance. Now that attendance which you have, Jaja will also have the attendance, Barnabas will also have the attendance, and so on. Everybody will have the same what? Attendance list, right? But then
Yes.
what if, let's say for instance, in my own record, in my own attendance, I added someone's name who was not present when that attendance was taken, right? So at the end of the day, if everybody is to bring his attendance so that, I mean, it is being checked to be sure that, okay, yes, we all have the same record, you see that mine is different because I added a name that doesn't exist in that initial attendance list, which you also don't have that name. Jada doesn't have that name. Barnabas also doesn't have what? That name, right? So in that case, I am trying to poison the
Yes.
attendance list. You understand? Yes. So basically,
Yes.
poison means, yes, I'm just trying to gain the attendance list so that I can include maybe my friends that will come and bribe me, or maybe just to include something that will be in my own favor. But then that particular record, or that particular record which I added, or that particular name which I added to the attendance list, it was initially not in the attendance list. So what I was trying to do at that point is to actually gain what the attendance list to my own self.
Yeah.
I
Thank you
don't know if
very
that's
much.
clear.
Yeah, it's
You're
clearer
welcome.
now. Thank you.
Okay. Yeah, any other question? Any other question? Okay, so basically there are some keywords here which we might want to actually explain. Yeah, we have things like the nodes here. So nodes. Now you might be asking him, you might be asking this question: what are nodes, or what is a node, right? Now, nodes are basically computers that participate in that blockchain network. Nodes are just your normal computers, your normal Dell computers, your normal HP computers, and so on. So anybody participating in a blockchain network is regarded to as what? A node. So they help to keep the network alive, keep the blockchain network what? Alive. So that's what a node is. And I think another keyword here is a block. Yeah, so we'll see block in the next section. So we also have chain, right? So chain is basically different blocks, shall I say, being arranged together, so that you know that, okay, from this block, the next block is this block, the next block is this block. So if you have, let's say, 10 blocks, right, all of them named 1 to 10. So from block 1, the next block is block 2, the next block is what? Block 3. So all those blocks are joined together, all those blocks are chained together, right? That is why it is being called chain. That's why you see the keyword chain there. So if anybody is having, let's say, different arrangement of block, or different chains of block, in that case, the person is not having the right word, shall I say, ledger of that particular blockchain itself. Yeah, so chain in this sense is just basically your blocks being arranged and joined together. Yeah, so I think those are just basically the keywords available here. So as we progress, any keyword, please, you see that you don't understand, you can just ask me, and then I explain that particular keyword. Yeah, so now let's think of the blockchain in our day-to-day activities, right? So I like to describe blockchain as a digital notebook, a shared digital notebook, right? So notebooks are things that you guys are familiar with in your schools, right? So you have your notebook. Let's say, for instance, your maths notebook, whereby you basically write anything you have been taught in school. So anything your teacher teaches you, yes, you guys all write it down, right? You have the same topics. Everybody in the class will have the same topic, the same content, and all that. So I'll be using that to explain the blockchain. So the blockchain is basically a digital notebook shared among many people, right? Now, when we said a digital notebook, we are basically replacing the word ledger to that digital notebook, right? Because we know that a ledger keeps track of what? All your transactions or all records. And then here, your digital notebook basically keeps track of what? All what you've been taught in class, the topics, the contents, and all that, right? So shared among many people. So in this case, all of you in the class have the same content of the notebook, right? everybody has the same content, the same topic, and all that. So now everybody can see a new page, which is basically a new block that has been added. Now, for any new topic, right, you have to add it to your own notebook. Now, any new topic, another person has to also add it to his own notebook and all that. So for every new page, in this case, I'll be using that to attribute it to what? Blocks, basically, blocks on the network. So for every new page, every new topic, right? Yes, you are basically writing it down, and then another person is also writing all those things down. Now, once you have written those particular topics and all that, right, you can't actually erase them. So the pages cannot be erased. It's as simple as that. Now, it doesn't mean that, let's say, for instance, I can't erase it on my own. I can erase it, but then the content I will have is different from the content you will have, and then different from the content that everybody will have. So at the end of the day, when our notebooks are being checked, it will be seen that my own content is different from you guys' content, from the content that you guys had, right? So as at that point, I am trying to actually gain, should I say, the class? Yes, I'm trying to gain the class since I'm using notebook, so I'll use class. I'm trying to gain the class. So maybe, for instance, the teacher might ask, okay, what was our last topic, right? If it's in mathematics, you guys will say, okay, last topic was algebra, and then I'll say, no, the last topic was not algebra. In my own notebook, maybe we can say last topic was quadratic equation. You can see that as at that point in time, my own content is different from the content that you guys have, right? And then with that, it basically means that I don't have the right word, or should I say the correct, yeah, let me use that word. I don't have the correct word, content of the notebook. I don't have the correct content of all the pages, right? So that is just basically the analogy. And then the content or topics in our notebooks can be attributed to us, or can be referred to as what? The transactions, right? For every content you add in your notebook, we can say, okay, that is basically a transaction. So the same thing, everybody will have new content whereby they add, and then that content can basically be referred to as what? The transactions, right? And then for every new page, right, that content can be referred to as what? The blocks. So for every new page, the page will be referred to as what? A new block. And then the notebook itself can be referred to as what? The blockchain. This whole section is what? Is the blockchain, right? This whole section is the blockchain. And then if you take a good look at this, you see, I think, about 5 blocks here: block 1, block 2, block 3, block 4, and then block 5, and so on. You can have as many blocks as possible. And if you look at this, block 1 is connected to block 2, block 2 is connected to block 3, block 3 is connected to block 4, block 4 is connected to block 5, and so on, right? So looking at this first block itself, you see that it has 3 different layers, or 3 different parts, right? So the first part is the transaction data. That's the first part, transaction data. Basically, transaction data is that part that contains information about that particular transaction, right? Now, this transaction data consists of all the transactions in this particular block. So you can have 20 transactions and so on, depending on the size of that block, right? So whether the transaction is for when you transfer maybe some tokens, or when you interact with the blockchain, that you try to write to the blockchain and all that. So this is the part that all the transactions will exist. And then if you look at all the blocks, right, they have all these parts. Now, the second part is the unique hash. So the unique hash is just basically a unique identifier of that particular block. It's just like a unique identity for that particular block, right? So that you can differentiate different blocks. So this block has its own unique hash, and then another block will have its own unique hash, and so on, right? And then the third part is the previous hash. So previous hash is just basically a hash, or yeah, previous hash is just basically what? The unique hash of the previous block. So let me explain this. Looking at this block 1 and then looking at block 2, right? You see that what connects block 1 and block 2 is what? Previous hash, right? Now, the unique hash of block 1 is what? The previous hash in what? Block 2. The unique hash in block 2 is what? The previous hash in what? Block 3, and so on, right? So this is what actually forms the chain. This is what actually distinguishes sorry, I say distinguishes. This is what actually shows which block is connected to the other block, and then which block is connected to other block, and so on, so that you know that okay, this block is the block that was basically mined or validated before this particular block, and so on. Yeah, so I don't know if there are any questions before I continue. Yeah, Peter.
This
Yeah.
previous hash, the previous hash is still also connected. The unique hash is the previous hash on block 2, but previous hash on block 1 is still referring to previous hash in block 2.
Okay. So yeah, this is not like previous hash is being connected to the hash. Yeah, it's just basically should I say this arrow being passed just to show you that okay, this is a previous hash, this is a previous hash, this is a previous hash, this is a previous hash.
Okay, sir. So what actually connects them together is the unique hash. On
Yes.
block 1 will be the previous hash of block 2.
Yes.
Okay, thank you, sir.
You're welcome. So looking at this particular diagram itself, you see how will I put it? You see some bubble-like structures here. Yeah, you see some bubble-like structures, right? So these bubble-like structures here basically represent the node itself. Yes, this bubble-like structure basically represent the node. And if you guys recall what I said about nodes, I said nodes are basically computers that participate in that blockchain network, right? Yeah, so basically, if you look at it, you see that they are all connected to each other. Yeah, you see that they are all connected to each other. So they share the same information across each other. When this person gets a transaction, he basically broadcasts it to the other's node, and then they also get that particular transaction and then add it to their own, shall I say, database. Yeah, and so on. And yeah, at the top of it, you see transactions that are pending. So pending transactions are just transactions that are basically awaiting validation and then adding them to the block, right? So once this transaction has been validated, it gets added to a particular block, and then it moves like that, like that, like that. And then the last thing here, you see something called consensus. Consensus. Now you basically know that consensus is just basically an agreement, right? So for a blockchain network, or yes, for a blockchain network to actually add a block, there has to be a consensus, right? And what is that consensus? You have to agree that yes, that particular block is valid. Basically, they have to agree that that block is valid, because if there is no consensus, then I mean, our blockchain today will have basically been useless, right? And why is that? Because if any block being presented to anybody, to any node, and then they accept it like that without any consensus mechanism to actually check if that particular block is valid or not, it means an attacker will just come and then propose a block that is not valid, right? And then once he does that, he basically gains what? The blockchain network itself. And when he gains that blockchain network, basically it means that network is poisoned. Because when something is not good, it means basically that thing is poisoned, right? So it means anybody can just come and then propose a block that is not valid, and then it will be added to the blockchain. And then, so it means basically at the end of the day, without consensus, our blockchain will just be just be another messy technology out there. Yeah, so these are like the basic components of your blockchain. You have the blocks, you have transactions, you have the consensus mechanism, and then you have the node itself. Yes. Any question? Yes, Barnabas.
Okay, James, sir.
Yes, Jim.
Yes, sir. My question is that, is there a point whereby I'll have maybe I created a valid block, and then in some time maybe the block gets, let me say, an error or something, maybe a transaction is missing or it hanged. I don't know, since is the blockchain is unchangeable and it's not controlled by anybody, how
Yes.
can someone go and now change it from maybe a lost transaction or a hand transaction, since no one can tamper with the block you created yourself?
Yeah, nice. So that's a very, very good question, right? That's a very, very good question. But then that's in the case of blockchain, right? In the case of blockchain, we said there are various computers scattered, right? And all those computers are connected to each other. All those computers have the same records and all. Now, when, for instance, a block is being proposed, right? Hope you know that blockchain basically deals with mathematical proofs, right? It deals with mathematical proofs. So when a block is being proposed, the validation of that block is just basically what some calculations, some mathematics that goes on behind the hood. And then once that block is valid, right? Once a transaction has been added to a block, you can't remove it. That's one. And then once that block has been validated and then sent to the network, you can't, in fact, you can't tamper with it. So if, let's say, for instance, you are trying to like tamper with this particular block, maybe let's say, for instance, you are trying to recompute that block and then you change a particular transaction data, the block will not be the same again. The block will not be the same again. So you see this hash, right? It's just basically based on the calculations that this hash is being generated. And then when a particular node is trying to validate this particular block, he gets this hash. If a node is trying to validate this block again, he gets the same hash. But then if any node tries to alter the data of this particular block, any data of this particular block at all, even if it is just the time that block was proposed, if that node alters it and then it is being validated, the hash will change entirely. It will change completely. It's just like your normal math. 1 plus 1 is 2, right? Now, if you change that maybe any value, either 1, maybe you put instead of 1 plus 1, you put 2 plus 1, it will give you what? 3. If you change it and put 1 plus 2, it will give you what? 3, right? If you change it and put 1 times 1, it will give you what? 1. You understand? So that is how the blockchain also works. It has some set of rules, right? Some set of rules that basically make sure that, okay, yes, this block is valid. And then any other node that is having that block will just have to make sure that, yes, the hash is the same. The computed hash is the same. Dave Mike, can you briefly tell us what a node is?
James, guys,
Yes.
a node is like all the participants that are on that chain, like all the participants, should I say all the computers that will be verifying the transactions, all of them, like the computers or the individual participants, the nodes.
Okay. Yeah, so Delshak, can you tell us what connects blocks together? What connects block 1 to block 2, what connects block 2 to block 3, and so on? Can you briefly tell us?
So the blocks are connected by this thing. What do they call it? Chain or previous hash? Should I call it a previous hash? It connects all this thing together. So every transaction, So every transaction has a hash. So all those hash is what connects the blocks together.
every transaction has a hash, and then it's that hash that connects the block together.
Yeah.
So are you trying to say that what connects blocks together is transaction hash?
No, they are interconnected by chain. I think it's not.
I don't agree with that answer. Yeah, Raphael, can you help us out?
No, the question is what connects different blocks, or was it transactions?
What connect blocks? Different blocks.
Is it not the transaction hash?
Transaction hash.
That's what ties one block to another. That's what connects one block to another.
Is it transaction hash or the block hash?
The block hash. No, the transaction hash. Sorry, the block hash.
No,
Sorry.
sorry, the block hash
The
that
block hash.
connects them together.
The block hash, because the
It's
block
the
has the block has a list of
hash.
transactions, and those transactions are also hashed to form the block hash. Sorry.
Yeah, please, you guys should not mix it up, right? It's like I said, like I explained, it is basically a bunch of transactions that makes up a block, right? And then that block, the hash of every block will be computed. Sorry, the hash of every transaction will be computed to get what the block hash, right? And then at the end of the day, it is the block hash that connects one block to the other. So, like we said, the unique hash rather of the first block is basically what the previous hash of what the second block. So the second block will know that okay, this is the block that precedes me, right? Based on the hash. So it can be able to locate that particular block. So I said we were talking about blocks and transactions, right? Even though we've been mentioning them, but we'll basically see what they are now. And then I said these are blocks, right? These are blocks. So who wants to oppose that? These are blocks. But in blockchain, these are not what we mean by blocks in blockchain, right? These are not what we mean by blocks in what? In blockchain. So blocks in blockchain is different. Now, what is a block? So a block is just basically a container, right? That holds all your transactions. Not all transactions are, but a container that holds some transactions per se. Yeah. So the definition I have here is a block is a digital immutable container of verified time-stamped transactional data. Please look at the keyword. Verified what? Time-stamped transactional data, cryptographically linked to the previous block. Now that's basically what a block is. Now, if you guys recall in the blockchain technology overview, whereby we saw how blocks are being linked to each other, right? Via what? Their hash, via their block hash, right? And then looking at this particular definition, please, the keywords there we have what? Verified. So it means for every transaction, right? For every transaction that has to be in a block, that transaction has to be what? Verified. That in fact the transaction cannot just be picked and then be added to the block. Like I said, I think it was Maraba that asked that question, and then I tried to explain that to him. So you can see here that for every transaction, it has to be verified, so that somebody won't just come and then try to do a malicious transaction, and then at the end of the day, it gets added to the block. I mean, it will poison the network, it will corrupt the network, right? So every transaction has to be what? Verified. And then if you look at the keyword here, it said immutable what? Container of verified. So it means for every transaction that is being added to the block, so long as it has been added, it cannot be what? Changed. Since it is immutable, it cannot be changed. And then those particular transactions basically consist time, right? Okay, this is the time that this transaction was made and all that. That's basically the way you do your normal record keeping, whereby you say, okay, this particular transaction, this person bought so at this time, this person bought so at this time, or I spent so at this particular time and all that. Now you have the transactions also what have time. They are also time stamped. This is the time that this transaction occurred, or this is the time that this transaction what happened. And then cryptographically linked to the previous block. Yes, this is just a big grammar that just basically tries to say that what each block is being linked to the previous block based on what the block hash, right? And then since we said the block hash is being generated via some computations, right? Now, those computations are basically what? Cryptography. So, like I said, mathematics is just basically what powers the blockchain, right? So, at the end of the day, all your transaction hash will be computed cryptographically, and then you get what? The hash of that particular block, so that the next block can be able to link to what? The current block using what? His hash. So the keywords here, we said the digital container, right? Yes, basically digital container. And the reason why we say digital container is because we are not referring to this block. No, we are not referring to this block, right? So what we are referring to is basically a block that exists in our computers, right? A block that is being created in our computers. So it is a digital container, right? And then the digital container stores what? Multiple transactions in one unit. So it contains a list of what? Various transactions, which is stored in what? In one unit. Next, we said immutable. I've already explained immutable. It basically means once that particular transaction has been added, data cannot be what? Cannot be changed or deleted. The moment you do that, it means that block will not be the same again. It's just basically like you creating a new block, right? And then since you basically be having the hash of the previous block, right? It won't basically tally. Yes, that's how your blockchain basically knows that, okay, no, this particular block is not valid. So this particular node is trying to do something fishy. Let's not allow him. And then verified, like I said, transactions must be what? Confirmed. They must be verified by the nodes before they are being added to the block. You don't just carry transaction and then add it to the block like that. By the time you do that, basically that block will be invalid. Now, I think it's also safe to actually attribute it to this also. It's just like saying, for instance, you have these blocks, right? And then these blocks are being connected by I don't know what to call this, but then basically cement, right? So if, let's say, for instance, now you did not include cement here, basically, I mean, these blocks will not hold each other. Definitely at some point they will fall off, right? So basically it has to be verified. Transactions have to be verified before they are being included in what? The block. And then timestamp. So each block has the time it was created. Basically, the time this particular block was created, it will have it just so that for record keeping, yeah, this block came before this block and so on. And then lastly, they are cryptographically what? Linked. So each block connects to the previous block via a unique hash forming a secure what? Chain. Yeah, I believe most of this part we've also explained it in the previous section, but yes, here you have it explained detailed, right? So in case someone asks you what's a block tomorrow, don't tell the person that a block is basically a component we use in building house. No. In blockchain, it's not the same, right? Even though yes, in blockchain, a block is basically a component that is being used to what, to build our blockchain. But then yeah, just try and make sure that you mention the keywords that basically say, okay, yeah, this is a block. Right. Next is transaction. Right. So what's a transaction? Yeah, you all know what transaction is. Basically sending and receiving money. Right. That's what you guys know as transactions, or what most people know as what transactions. But then in blockchain, it's a bit different. Yes, even though at some point you send tokens and all that, you make transfers, but transaction is basically a record of an action, right? It's basically a record of an action or transfer of value that is verified and recorded on the blockchain. So let me explain that. Now, like I said, most of you must have been familiar with what the transfer of value part of it, right? And what do I mean by that? Basically, let's say for instance, I want to send maybe Barnabas some token. I want to send him some stack, some STRK or some USDC, right? Yeah, so that is basically the transaction, the transfer of what? Yeah, the transaction that has to do with what? Transfer of what? Value. But then how about the action part? Now, let's say for instance, you are interacting with a DApp, a decentralized application, right? Basically, a decentralized application is an application that is being built on the blockchain. That's why it is called a decentralized application. So let's say you're trying to interact with a game. Yeah, let me use a game that is being built on the blockchain. So when you create an account on that particular game, basically it is an action, right? It is an action you are doing. In that case, you are not sending money using the blockchain. You are not transferring value. You are not transferring tokens. It's an action you are doing. And what's that action? Registering, right? Registration is that action. Now, any action you do on a decentralized application that requires you to like sign that particular transaction or approve it using your wallet and all that, it is basically referred to as what? A transaction. Basically referred to as what? A transaction. So here, excuse me, transactions are what? Action based, right? And then when we say something is action based, it's basically it's an occurrence of something, right? So let's say for instance now you want to register on that particular game, you are performing an action, right? And then that is what? Registration. Let's say you want to transfer money, you want to transfer value, you are performing an action, right? And then the action is what? The transfer of what? The value. So here, the action base basically represents an event, right? Such as sending or receiving cryptocurrency or basically registering on a platform and all that. Now, verified. Transaction must be confirmed. I think this is like the third time we are mentioning the transaction must be confirmed before it is being added to a block. You can't just bring any transaction and then throw it and then it gets added to the block. No, it has to be confirmed. It has to be verified. They have to make sure that yes, it is valid before it is being added to what? To the blockchain. And then immutable, same thing as the block. Once it's recorded, it cannot be altered or deleted. You cannot edit it. That's one. You cannot delete it. But then there was something I made mention at first. I said, yes, the immutability of blockchain is just basically that the transaction or that particular thing, that particular transaction cannot be changed or deleted. But then you can actually maybe make an update. Let's say, for instance, when you're registering on that particular game, right? You use, let's say, for instance, the name Barnabas. Sorry, Barnabas, you have to bear with me today. Let's say you use the name Barnabas, right? And then later you want to change your username, maybe to, let's say, New King or something like that. Now, You changing the username doesn't mean that Barnabas has been deleted. No, it will be recorded that yes, your name was once what? Barnabas. That's how it will be recorded. It will be recorded that yes, your name was once Barnabas. So you see that the data was not deleted, right? And then that Barnabas itself was not changed. If you still go back, you still see Barnabas as Barnabas. It's just that currently Barnabas is not using Barnabas. The same thing will happen when, let's say, for instance, you are transferring your token, right? We are transferring tokens. Let's say, for instance, you have 50,000 stack, for instance, right? And then you want to transfer 10,000 stack. Now, it doesn't mean that that 50,000 stack that was recorded before will be deleted. No. If your wallet is being audited, like maybe being checked, you see that, okay, before you had 50,000, and then later you transfer 10,000. And then after you can transfer 10,000 stack, you are now having what? 40,000 stack, right? The record doesn't get deleted. The only thing that changed is just what? The state. But then the record is of the previous state is also being kept. It can always be referenced. Now, timestamp. Also, every transaction has a timestamp. It has a time that it occurred, right? Yes, okay. This transaction occurred as so this person transferred 10,000 stack. Barnabas transferred 10,000 stack to Joshua by this time on this day, right? Yes, it also has timestamp. The same way your block also has what? Timestamp. Because you guys know that blockchain is all about what? Transparency, right? So if you want something to be transparent, it means you must include every necessary, should I say, trail, yes, or every necessary details that will prove the transaction to be okay, yes, valid, so that as you're trying to make it transparent, yes, people can actually see that, okay, yes, this particular thing happened at this particular point in time, and so on, right? Then lastly, we said linked. Now, transaction, we said when they are confirmed, they get added to what? A block, right? When they are verified, they get added to what? A block, right? So at the end of the day, when they want to be added to the blockchain, yes, when they want to be linked or want to be added to the blockchain, they have to be verified. And then when they are verified, right, then they get added to the block. So them being added to the block, basically, they become part of what? The network, the blockchain itself. And then here, we said it basically, when transaction is linked, it becomes part of a block that is cryptographically connected to what? The blockchain. That's basically what a transaction means. Transaction is not just all about sending money, right? Yes. Transaction is not all about sending money or give me, I give you. It's at some point, it's also what? An action, right? It's also an event. When, for instance, now I register on this game, yes, this is it. Or let's say, for instance, you have a land registry system, right? Whereby you come and register your land and people can come and see the land. And then when the person now buys the land, you now maybe transfer the ownership for the person, right? Basically, that's an action or a series of events. You coming to the platform, registering your land on that platform is an event, right? Another person coming to the platform, buying that land is an event, right? You transferring the ownership is also what? An event. So basically, that is the transaction. And then here, if you look at this simple image, you see basically, shall I say, is simple overview or high level overview of how transaction occurs, right? First of all, you have the creation of that transaction, yeah, the creation and the action. Then next is what? Verification. So it has to be verified, right? It has to be verified. After it has been verified, it gets added to what? The block itself. And then after it has been added to the block, yeah, basically you have the time it has been, it was verified and all that, and then it gets stored on what? The blockchain. It's as simple as that. So, Clement, can you tell us the difference between between a timestamp in a transaction and then a timestamp in a block?
Okay, so the timestamp in a transaction is basically the exact time the transaction happened.
Mm-hmm.
I don't know. You said timestamp in a transaction and timestamp
In a block.
okay. So in a block is basically the exact time that block was validated and added to the blockchain.
Sandy John, is he correct?
Yeah, I didn't quite speak him, but timestamp in transaction is basically the time where a transaction is being created, while for blocks, a timestamp is actually the time a block is validated.
Okay, so yeah, any question before we move on?
Can I say any anything that would change the states of the blockchain or add a block? We can call it a transaction.
Yes, in some sense, yes.
Okay, sir.
Yes, but then basically it has to have actually like the should I say attributes of a transaction itself. You get?
Can you come again? It's like my network was cracking.
Okay. I
Okay, I
said
can hear you
yes.
now.
Yes, I said okay. What you said, yes, basically in some sense, that is it. Anything that can change the state of the blockchain is basically can be referred to as a transaction, but then it must have the attributes of the transaction itself.
Okay, sir.
Yeah,
Thank you.
you're welcome. Any other question? Okay, yeah, no question. So now let's basically look at how the blockchain works, right? Let's look at how the blockchain works. Now, we've established that the blockchain comprises of blocks, right? It comprises of transactions, and then it also comprises of nodes, right? Yeah. So the way it works is, first of all, transaction will have to be broadcasted by the node, right? They will have to be broadcasted by the node, and then once they have been broadcasted, and then the transactions are valid, right? The next thing is they get what added to the block. And then once they have been added to a block, right? Then the next thing is that block also needs to be what? Validated. To be sure that yes, everything is fine. So once the block has been validated, then basically it gets added to the chain itself. So that is just a high level overview of how the blockchain works. But then basically here it is. So transactions, first of all, are being broadcasted toward the network of nodes, right? And then you guys recall what we said about the nodes. Nodes are basically computers that would participate in that particular blockchain network, right? So transactions are being broadcasted to all those nodes, broadcasted to all the nodes, right? So the way it works is, first of all, when someone makes a transaction, right, it is not sent to maybe one authority just like that. So instead, it will be shared across all those computers, shared across all those nodes on that particular network. And then now let me try and explain this in Ethereum. So the blockchain basically uses this concept of gossip, right? You guys know how gossip works. I know each and every one of you here must have gossip. at some point in his life. So you guys know how gossip works, right? Yeah, you get the gist, and then, hey, John, look at this gist to blah blah blah. I tell John, hey, Barnabas, look at this gist to Barnabas will tell Joshua. Before you know, all of us will will definitely have that gist, right? So that is how the blockchain works. That is what transaction broadcasting means. It is that gossip. If not that, people are saying transactions were created, blockchain were created by these guys and these guys. Me, I would have said it must have been an idea of maybe no shade is taken, but then women to actually make sure that transactions are being broadcasted to the network, right? Because like it's a very brilliant idea. In this case, gossip is very, very important, because without gossip, imagine transaction being sent to a central authority. It is that authority that will have everything over transaction and all. It means the network itself is not safe. So that is why gossip in this case is very important. That is the concept that blockchain also uses. Gossip, right? So once you get that transaction, you broadcast it over the network itself. And then once it broadcasts it, every other node will also get the gist of that particular transaction, right? So the next is the nodes validate transaction using the consensus mechanism. Now, you guys recall what we said about consensus, right? Consensus basically, let's say for instance, some set of rules, right, that you all must agree with, whereby everybody must agree with, right? So that is what the blockchain uses to also validate what transactions. That is what all those nodes, all those nodes use to validate what transactions, right? So each of the nodes will have to check that, okay, yeah, this transaction is valid. That's what they do. In the case of sending, let's say value, they'll have to check that, okay, yeah, this person has up to that amount, right? In the case of, let's say for instance, the events, the action, right? Maybe like registering, they'll have to check that, okay, yes, this particular user have maybe the privilege to actually do this particular action. Because there are some cases whereby, let's say for instance, an airdrop now, for you to be able to claim an airdrop, you have to be what? Eligible, right? So that action of claiming, right? They will have to check that, okay, yes, this person has what? Some allocation of that particular token to claim for that airdrop. That is basically it. So each node will have to check that the transaction is valid, right? And then how do they do that? They have some set of rules that they use. So they for them to actually agree on a particular on the transaction, it means the transaction will have to basically pass those rules, right? So even if one of that rule is being broken, then forget it. That transaction is not valid, right? So that is how those nodes know that, okay, yeah, this particular transaction is valid or not. I think Barnabas asked that question. So you can see it based on the consensus rules, right? If anything is being altered in that particular transaction, then forget it. That transaction is not valid, right? So those nodes, they have to agree on which transactions are legitimate or not. And then basically the network, that the blockchain network itself, uses what? The consensus mechanisms. So there are lots and lots of what? Consensus mechanism. But then these are like the most popular ones currently. One is what? The proof of work, right? So those nodes will solve what? Complex puzzles to validate the transaction. That's in the case of Bitcoin then. Currently, yes, Bitcoin still uses a proof of work, right? So all the nodes will have to solve some puzzles, and those puzzles are basically mathematical computations, right? They will have to solve those puzzles to be able to validate those transactions. Ethereum, at first, yes, that's what they were doing. Also, they were also using both the proof of work before the transition to proof of stake. Now, for proof of stake, the consensus mechanism, those nodes are being chosen at random, right? Then when they are being chosen, they validate the transaction, and then at the end of the day, they now broadcast it to everybody. So now you might be asking, why all this? Why does the transaction have to go through all these threads of the consensus mechanism, like for Bitcoin now, to solve those complex puzzles and all that? Now, it is just basically because they want, shall I say, a single truth. And what do I mean by single truth? It means basically the record I have, you are also expected to have that same record. The record you have, Delta is expected to also have what? The same record, right? And then how are we going to have the same record? We can only have that same record if I validate it, and then he gave me the same thing. You validate it, he gave you the same thing, and Delta also validates it and then give Delta the same thing, right? Now let me use math for instance. Let's say, for instance, I'm trying to solve a quadratic equation, and then at the end of the day, I get my answer. If you're also solving the quadratic equation, right, it's expected that your answer should be also be the same with mine. Now, if your answer is not the same with mine, it means it's either I solve it wrongly or you solve it what? Wrongly, right? So that is how it works. Now, here I say this whole validation of transaction by the consensus mechanism just basically to ensure that everyone on that particular network agrees on that particular state, right? And then how do they agree on that? The transaction has to be the same at the end of the day. The computation, right, has to be the same for me. It also has to be the same for Barnabas. It also has to be the same for Delshad. It also has to be the same for Joshua, and so on. That is the only way we'll be like, okay, yes, this is right. Back then, I remember when we were trying to or when we were doing some maths then in secondary school, I will solve it, right? I'm not sure of my answer. My classmate, maybe the next person next to me will also have to solve it. And then we compare the answer. Is it the same? Okay, no, it's not the same. Am I the one that did it wrong, or is it this person that did it wrong, and all that? So at the end of the day, if I solve and then you solve and then we get the same answer, it basically means yes, that particular this thing is right. You understand? So the same way, for transactions to be added to the blockchain, it means they all have to be what? Valid. It means everybody has to be sure that yes, this particular transaction is valid, right? Now, next, once that transaction has been validated, right, then that's when they are being added to the block. And then we all know that blocks are basically changed together. Blocks are basically changed together. And then blocks contains what? Many transactions that have been validated, right? So valid transactions are grouped into what? A block. And then at the end of the day, each of those blocks is connected to a previous block. Now that is the concept of the chain. This particular new block now must be connected to what? The previous block. So the next block that we propose must be connected to this current block and all that. So they are being connected to the previous block using what? A cryptographic hash. You guys remember our unique hash, our unique block hash, right? Now it is that connection of what? Those particular blocks using the what? The cryptographic hash that forms what? The chain of the blocks. That particular what? Connection of what? The blocks using the cryptographic hash is what forms what? The chain of blocks. And then that's why you have the word blockchain. Blockchain is just basically what? Blocks, different blocks chained together. Yes. And then this is what makes the data secure and immutable once added. It can't be changed without affecting the entire chain. So like I said, so long as you are making a chain, even if it's just a tiny chain, even if it is just, let's say for instance, for the timestamp, right? Maybe you change the last number, maybe from 0 to 1. It will affect the chain. It will affect the transaction. It will affect the block. right? So that is basically how the blockchain works. Guys, ask your questions. I know you guys have tons and tons and tons of questions. So please ask your questions. You guys know that if you don't ask questions, me, I will ask you. Yes, Barnabas.
Okay, concerning this consensus, so it means that a that a computer cannot serve as a node if the computer does not agree to the consensus.
Yes, basically.
Okay, so it means that as long as you are an active node, when a transaction is sent and you want to say, okay, this for example, by mistake, your node verifies the transaction wrongly or is having different results. So what happens to that particular node?
Yeah, so in the case of Ethereum, which is proof of stake, right? You get slashed. You know that for proof of stake, for you to be a node, you have to stake some money, right? You have to stake ETH in Ethereum, about 32 ETH. So if you do anything wrongly, right, you get slashed. There's a penalty for it. Even if, let's say, for instance, you go offline as a node, there's a penalty for it.
Okay, I understand.
You understand? Yes. So that's also part of the consensus mechanism, just to be sure that, okay, this person have something in stake. So if he does anything wrongly, he gets slashed.
Okay, I understand. Thank you, sir.
Yes. You're welcome. So if you are trying to invalidate a transaction or trying to manipulate anything, it's your money. Right? It's your money. You just keep getting slashed. Yeah, any other question? Okay. So this is just an illustration of how it works. First of all, right, when a transaction is being sent, it needs to get broadcasted, right? So once it's broadcasted, it gets validated by the node. So depending on the consensus mechanism, like we said, for Bitcoin is proof of work, basically solving what? Complex puzzles, right? But then for like the likes of Ethereum is what? Proof of stake. Basically, you have to stake some collateral, right? So after it has been validated, then it gets added to what? A block. So it gets added to a particular block, and then at the end of the day, once that block has been validated also, then it gets added to what? To the chain. So as more blocks are being created, they get added to the chain. More blocks, as more blocks are being created, they get added to the chain. And also, as more transactions are being created, they get added to what? The block. And then and so on and so forth. That's how it continues. Yes, any question?
Yes, sir, I have a question. Can you hear me?
Yes, I can hear you.
So, for example, I send one transaction.
Okay.
It will create one block, right? And for example, I send another transaction. Will it add to that block, or that block is just it will create another block, and then at the end of the day, send all the blocks, or it will create one block that will hold all the transactions, then send the one block.
Okay. So when you make a transaction, right?
Yes, sir.
What gets when you make a transaction, it's not your transaction that creates the block. A block is created there for everybody to come and sorry, not everybody, for transactions to be added. So it is not only your transaction that has been added to a block.
Okay.
You understand? Yes. Because
Yes, sir.
Yes, so the block must have to be filled before it gets added to the chain, right?
Yes, sir.
Yeah, a block has
Yeah,
to
I
be
can hear you.
yes, a block has to be filled before it gets added to the chain. So let me quickly show you guys this. So this is basically transaction CT. Yeah, so if you scroll down, if you scroll down, you keep seeing all these people. So these people are transactions, right? They are all transactions. And then if you look at these are like basically protocols, or basically protocols, or uh different types of transactions that come in. Now, all these guys are transactions, all these people are transactions, all of them, they are transactions. And then these here are blocks, right? These here are all what? Blocks. So you see that it's not one block that is being created and then just kept like that. So for every block created, you see transactions in it. So till when that particular block is full, right? That is when um it gets added to the chain, and then those other new blocks will now be what? Will now be let's say in the queue for them to actually uh get all those transactions and then pre-fill it and then move on. So as you can see, minutes by minute transaction keeps coming. Minutes by minute transaction keeps coming. And then as it comes, they all get added to what? To the block. Right? As it comes, they all get added to the block. As they are being validated, they get added to the block and so on. So if you look at this illustration, you see sometimes you see a block becoming larger than maybe another block. So the reason why the boss or the block is becoming larger is because of what? The number of transaction size. If the transactions are much, then the block becomes bigger and all that. So it's not like, let's say, one transaction and one block will be created for a particular user or a particular wallet address, right? So all these transactions are being created by different people, by different wallet addresses, and
Yes,
then
sir.
all gets added into the block.
Sir, can you hear me?
Yes.
Sorry to cut you. I want to just ask one question again. So, is it like a block has a particular transaction it can hold before other transaction can
Yes. Not
be added to another?
Yes, so not really. Most times it depends on the blockchain itself, right? Because every blockchain have their yes, every blockchain has their own way of doing things. For some, right, they have basically like a time, right? So they have a time. If let's say for instance, after this particular number of time, it is just the number of transactions available will be added to the blockchain. For some, it depends on the number of transactions, right? For some, it depends on the number of transactions. So if let's say, for instance, maybe let's say the number of transactions of this particular blockchain is, let's say, that this particular blockchain is allowing per block is, let's say, for instance, 10. The moment 10 transactions in that particular block, then automatically the blocks get what? Get added. And then for some, like I said, for those that usually use time. So let's say, for instance, a block will be created every, maybe let's say, for instance, 12 seconds. Let's say, for example, right? And then once it is after 12 seconds, the transactions in that block will now be what? Will just be added to the chain directly. So it depends on the blockchain itself. So basically we've been talking about blockchain and all, blockchain and all, blockchain and all. So now, what are the use cases of blockchain? Where can we use blockchain effectively? So let me see. Yeah, Joshua.
Okay, I think one use case of blockchain is to validate transaction.
Mm, That's not a use case. That is validation of transaction is part of the blockchain, is what makes up the blockchain also. Yes, Arome, can you give us one use case of blockchain?
Blockchain can be used for payments.
Okay, yeah, in payment. Yes.
Yes.
Sandy John, what other use case of blockchain? What's another use case of blockchain? Sandy, are
Hello,
you
sir.
there? Yeah, Joshua.
So can blockchain be used like to keep permanent records of things?
Yes. In fact, that's like that's like how would I even put it? For every application that uses the blockchain, that's just what happens. All the records are permanent. Yes, Sandy John, are you there? Jaja, can you help us out? One use case of blockchain.
Okay, Gem boss.
Yeah,
Is
Gem.
for building dApps, decentralized applications that
Yes, like what type of decentralized applications? Can you just give us one type of decentralized application that can be built using the blockchain? All right, so let's not waste much time. Now, blockchain has lots and lots of use cases, a whole lot of use cases, right? I believe the most common one is in finance, where you guys send USDC or USDT, you guys send Stark, you guys send Ether, and so on, right? So that is the most widely used case of blockchain currently, right? But then we also have other use cases, like we have in supply chain, right? So how is blockchain useful in supply chain management? You know, basically supply chain management deals with let's say movement of products from one location to the other location, right? And then basically let me say from the source to the destination. And then how is blockchain useful in that case? It's useful because for every particular transaction, for every word, action, every event, it is record and then it is permanent. And then with that being said, it means nobody can come and say, okay, no, immediately from the from this particular place, I went here and all that. No, everything will be tracked. Everything, because you guys remember that the blockchain is basically public for anybody to actually get access to. So I can just go to the block explorer itself and then basically check the particular action on that particular should I say order and all that, and then I'll see everything there. So it means nobody can lie to you. Now another use case is voting. This is I think we need to even embrace this, but then I won't say much than this. So in voting, right? Every transaction, so long as you do it, everybody will see it immediately, and then it cannot be changed, right? So that is a very good use case for voting. That is a very good use case of voting. And then if you all agree with me, and then if you can use your initiative, you guys will see a reason why I said we need this. You guys will see a reason why I said we need this. Why we need blockchain in our voting system. Yeah, why we need a blockchain in our voting system. Because if I cast my vote, nobody can go and change it. My vote is my vote. And everybody can see it, can see that, okay, yes, this particular vote has been counted, right? Another use case is in healthcare. Now, health records can be stored in the blockchain. Can be stored on the blockchain, basically. right? And when health records are stored, we just forget about things like, okay, hey, sorry, my house got burned, and then maybe my all the tests I've done before have yeah, all the tests I've done before were set ablaze also in the fire. Or maybe, for instance, the hospital, eventually something happens, right? And then basically your records will no longer be there. So at the end of the day, all those past records of patients will be missing. But then with the blockchain, I mean, if, let's say, for instance, my own computer goes off, there are other computers that have the same record. So everything can be accessed there, right? It keeps track of every transaction, every action, every event. So I mean, it can be accessed anywhere. There's nothing like, oh, I mean, fire service came and then they couldn't put off the fire on time, and then your records were burned. Or let's say, for instance, hurricane came and then scattered the building with documents and all that. No, there's nothing like that. Like I said, even if one node is down, the other nodes will be what? Active. Now, like I said, in real estate, you guys recall I made mention of land registry. Let's say, for instance, you register your land, someone comes and then buys the lands and all that. Yes. In fact, blockchain is very useful in that case. Because let's say, for instance, for every land, the person can actually get, the owner can own a unique NFT, right? That NFT, nobody can own that NFT again. So when, let's say, for instance, the owner is selling that that land, he has to transfer that NFT also to what? To the new owner. Yes. And then at the end of the day, all those transactions will occur. You see the previous owner, you see the current owner. So you that is coming to buy the land, I mean, you can see everything, and then you'll be sure that, okay, yes, this land is what is valid. Because I think in Nigeria or Africa, we've had several cases of what land fraudulent activities going on, whereby someone will go and sell a land that he doesn't own, and then at the end of the day, when I start building, the real owner will come and tell him that, hey, this is his land. And then even if we go to court, I will lose the case. So blockchain can also be useful in what? Estate management. Yeah, so the next is in digital identity, right? So digital identity basically has to do with what? Your personal identity, right? My identity, your identity, everybody's identity that can actually be verified. Now, let's just shall I say, annotate this to what's happening currently. Now, I might have my real identity, but then I might go and create another different identity, right? That doesn't belong to me. Maybe different name and all that. But then since we are using a centralized platform, most times it will be hard for it to actually be verified that, okay, no, this person is this person. This person has already been verified as this person. Most times you have to do a whole lot of efforts and all that. But then if you are bringing that to blockchain, there's what we call a zero knowledge proof. Basically, in that case, for every identity, right, there's a proof of that particular identity. And when I'm coming to actually verify a user, in fact, I don't even need to actually reveal the details of that user before I'll know if that particular identity is valid or not, right? So blockchain can also be useful in this case. Now, these are just a few of the useful these are just a few of the use cases of blockchain. But then there are other use cases also. But then, like I said, the one most people are conversant with is the finance, right? Because I mean, people are all about money. Yes, people are all about money. But then, yes, blockchain can also be useful for social media. Yes, in social media, blockchain can also be useful. And then why is that? Because you as a user making that post, you basically have that data. It is your data, right? So that somebody cannot just come and then be selling your data like that. No, you own that data. So for anybody to even sell that data, it has to be you. You have to be the one to sell that data to another person. All right. So there are other several use cases of the blockchain, but then these are just few of it. Yes. Any question or any contribution? Maybe since you guys have seen these few use cases, you guys can maybe think of another use case and then be like, okay, yeah, blockchain can also be used here. It can also be used here and here and here and here and here. Yes, anybody have any use case for us?
So how about in content creation and like books?
Beautiful, yes. Blockchain can also be used in content creation. I think currently there are some platforms, I can't mention their name, yes, but then there are some platforms that, in fact, they have should I say their niche completely is on what? Content creators, or for content creators, basically, right? Because like I said, you as a content creator, you own that data, right? I won't mention name, but then there are some platforms that you as a content creator, at the end of the day, your content might be used for other things, and then you won't even earn anything from it. But then in the case of blockchain, most times content creators even make money from their content, right? You create a post and then people can actually pay you for that post and all that. Your fans can contribute directly to you. There is no third party, no central control. Yeah, that's also a very good use case. Any other person? Just one more person, and then we proceed. Any other use case?
Hello, sir.
Yes.
I have seen like blockchain being used for educational systems, whereby maybe you do a course and your certificate is an NFT.
Yes.
So you can mint the NFT as your certificate. So I want to ask, is there a way that, for example, like our grading system that say, okay, these are first class, second class, so this specific NFT is for this particular set. In a situation like that, is there a way that this can be differentiated since these things are decentralized? Like, how can we say that the people that have first class will mint this particular NFT? Is there a way that this can be verified to make sure that these particular people are the one minting this particular NFT, since everything is decentralized? Is there a way that it's possible? Because
Yes,
anybody can actually mint that particular.
there's a way. It's very possible. So when creating the NFTs, I mean, you can create different variations of that NFT. For those with first class, I mean, this is the NFT you issue them. For those with second class upper, this is the NFT you issue. For those with second class lower, this is the NFT you issue, right? So if let's say, for instance, I'm a first class student, what basically will be issued to me is that NFT that belongs to the first class student. And I mean, most times for cases like that, which I've seen, you see the names of the individuals on it, right? And then even if someone is going to, like, maybe I mean, we have graphic designers now, even if someone wants to go and maybe replicate that, but then there is, remember that the blockchain deals with what? A cryptographic hash. So the particular address of that NFT will not be the same, right? So even if another person go and use maybe the same design and then put his name and all that, when he comes to the platform for verification, I mean, they don't know that particular address of that NFT which he created. They only know the one that is being issued by either the school or maybe that particular platform that issues that certificate. You understand? So, and then those platforms, I mean, they know the first class student, they know those that basically are the second class students and all that. So for platforms that really want to go maybe completely, let's say, decentralized now, what they might do is they might just have a platform that once you take that exam, right, the moment you finish that exam, maybe depending on your scores and all that, already you know that okay, um this is what's the name, maybe the grade of that particular student, right? So I mean, it's very, very possible. I don't know
Oh,
if that's clear.
yeah, that's clear. Thank you.
You're welcome. All right, so let's move to the next section, which basically talks about the challenges and limitations. I mean, you can't tell me that the blockchain doesn't have challenges, right? You can't tell me that the blockchain doesn't have challenges. We all know that every technology we have today have what his or her own what challenges and limitations. Now, one of the challenges is scalability, right? And then what do we mean by scalability? We mean transactions are slow. Yes, most times transactions are slow. I think prior before now, transactions most times are very slow. Sometimes it takes up to 3 to 15 minutes for transactions to process, right? But then at least now the speed is increasing. But then still, when the network is busy, when there's network congestion, right, the transactions are still slow, and then that's a problem. That's a problem. Now the next problem is, or next challenge is the cost of transactions. I mean, for you to be able to keep the blockchain secured, it means users have to pay like a little fee for it, right? And then let me also explain why that is important. So imagine, let's say for instance, users are not paying a fee for transaction. Somebody can just come and then just be doing a whole lot of stuff that, I mean, are not even supposed to. You understand? Because I mean, if you look at your Web2 systems today, your centralized applications, most time you see somebody just coming on board and then doing anything he wants to do. I mean, because he's not paying for it, right? He's not paying for it. So he just come do anything he wants to do, and then that's all. And also, apart from that, one of the reasons why transactions are being paid for is also as a way of securing the network. And then how does transaction fee secure the network? Now, for every transaction, I mean, you know that you have to pay for it, right? So imagine a user not paying for a transaction. And one good thing about the blockchain is that so long as you give it enough time, resources, right, it will be able to solve any computation. Any computation. So most times, in the case of Ethereum, it's being regarded to as a Turing complete machine. Hope you know that a Turing complete machine is just a machine that, so long as you give it enough time and resource, it will solve any computation you give it, right? So also is the blockchain. It will solve any computation. And then imagine users just coming and then there's no fee. So they just keep congesting the blockchain network, making the blockchain network congested, right? And then users that actually want to perform real transactions might find it frustrating to even perform transactions. Sometimes their transaction will not even be processed till when those guys are done with their stuff before it gets processed. So with that transaction fee now, if you want to come and do your rubbish, it's your money. The blockchain will solve all the computation. But then once you run out of gas fee, then I mean that marks the end of your transaction processing, right? And then with that, I mean the network continues. So you see that transaction fee itself is a way of securing the network, right? But then when there is a peak usage, that is when the network is busy itself, this scalability, when the network is busy itself, there is high what transaction costs. Transaction fees become higher, right? Yes, they become higher. And then with that is a problem because I might not have enough money to pay for the transaction fee, right? So I mean, when transaction becomes expensive, I will have to like wait for when it to be less expensive before I perform my transaction. And who has that time? Now, the next challenge is also what energy consumption. Now, in the case of proof of work, remember we said for like Bitcoin, which is the proof of work, it solves complex what I say transaction. Yeah, it solves complex puzzles, right? And then solving that puzzles has to deal with what? High computation power. It has to do with high computation power. And the process of solving that particular puzzle is called mining, right? So when a particular node is trying to mine, there is high energy consumption by the computer. The computer requires a high a resource, right? It demands high resource, and at that you have to spend more on electricity because I mean you have to keep that computer active, right? And then the more it mines, the more it consumes more resources, the higher the demand also. So it's also energy consumption. Now, next is data privacy. I mean, transactions are public. I've been saying this. Anybody can go and see transactions there. So data privacy in that case is what is defeated. Even though there is what we call a public blockchain and then a private blockchain. So public blockchain is a blockchain that I mean most of us have been using, and then private blockchains are blockchains that maybe are being created for just a particular organization and all. But then still, the people in that organization will still see all the transactions there. So you see that data privacy also is a problem. Data are not private, right? Next is complexity. I mean, this is like the major problem whereby users usually face, especially newcomers, right? Because for someone who have no knowledge of the blockchain, right? Someone who have no knowledge of what wallet is and all that, when he tries to interact with the blockchain, he finds it very difficult. It is very complex. I think till date, at some point, I still find it complex, especially in the aspect of DeFi. There are a lot of complexities there, right? So for beginners, it is mostly complex for them to even understand it. For business, for businesses, yes, sometimes they usually find it a bit hard to actually implement it because the blockchain have his or her own rules which you need to follow, right? So if you want to go out of the that particular rule or go out of that way, then it means you find it hard, you find it very difficult, right? So these are just few of the challenges and limitations. We also have user experience. User experience of blockchain is also very poor. Very, very poor. I mean, thankfully now, I mean, it's improving, but then you have to download some applications for you to be able to interact with the blockchain, which are basically wallets. And then for you to be interact with a decentralized application on your mobile phone, you have to basically make use of what? The browser in that particular wallet. So you can't even use your normal browser and all that. But then thankfully now, I mean, the user experience is being improved in that sense. And then, yes, bit by bit, solutions are being provided for these challenges. And hopefully, a time will come whereby we will be interacting with Web3 applications, basically central applications like our normal Web2 applications. Yeah, so these are just the few challenges and limitations. I don't know if you guys have any question or if you have any contribution, any addition. Yes, you can. The floor is open. Yes, anyone? Any question, any contribution? Nobody. All right, so let me ask this question. How many of you have interacted with the blockchain? Let me see your thumbs up. Okay, Barnabas, Sati, Delshark. Yeah, nice. So from your interaction, was it smooth? Okay. Yeah, so I think Peter said no, it wasn't smooth. So yeah, Peter, can you briefly tell us yeah, Peter and Sati. Yeah, so just the two of you. I will start with Peter. Can you briefly tell us the challenge you faced?
Well, for me, why I say it wasn't smooth, not like all wasn't smooth. Yeah, sometimes it's smooth, but there was one time like that I sent um Bitcoin from one wallet to another. So, because of the price dropping down, the Bitcoin refused to send for over 2 days. So showing pending until the price went up to that particular amount, where the amount it was when the transaction was being processed, then before this now finally sent. So the time it wasted was
Yeah, you see, so that's also a problem. Yeah, so Charles.
Yeah, so I have also had a lot of problems with the blockchain, especially the first time I interacted with the blockchain. I mean, also today, I keep finding some seed phrases that I have written a long time ago, that I kept somewhere. And the problem with that is that you keep forget, you cannot even catch that seed phrase in your head. You keep forgetting what it is. And sometimes you want to come and import the wallet back, but you've forgotten where you kept it. And then you have to now create a new wallet. And all of this creation of new wallets is quite complex. And sometimes you even have money in other wallet and you forgot what the seed phrase is. And you cannot even recover it because you don't know what that seed phrase is.
Exactly. So you see,
Yeah.
these are all challenges that exist, and then there are also more, right? There are also more. But then
Yeah.
on Starknet, if you are using Agent Wallet, right, you can basically make use of the social sign in. So that whole what's the name? The whole seed phrase and all that. You don't even need to bother yourself about it, right? So you can see that currently now, these what's the name? These particular problems or challenges are being solved day by day, right? And then also, I think Delshark said he once sent $16. $13 was used as gas fee. Yes. So you guys see what we said about transaction cost and then the scalability, right? So this particular transaction cost was because of the scalability issue, right? Yeah, so that was why the fee was high. But thankfully, we have some solutions currently that basically aims to actually address these particular issues. Any solution to these challenges? Yes, there are solutions to these challenges, right? There's a solution to this challenge. And then what's that solution? Who can guess before we hit the drum roll? All right. You said?
I want to say something, but it's not concerning the solution yet.
Okay.
Sometimes if I'm sending maybe USDT through Web20,
Yeah.
yes. So sometimes you see before it get deposited to where I'm sending it, it will tell you that it has to do like 60 confirmations. So is it the same as validating with the notes, or is a different thing?
Yeah, it's the same.
Okay.
Yeah.
So it has to go to different people to validate the transaction before it gets approved.
Yes, to be sure that it's valid.
Okay.
Yeah.
So it means that sometimes it used to take time. That means another challenge it has is time something. Sometimes it's not fast.
Yeah, sometimes, but I mean, those are like things that actually need to put to be put in place just to make sure that it is secure. Because imagine someone just sending, maybe it's just one confirmation, or someone just sent a malicious transaction, and then it was maybe confirmed once, and then basically it gets added, and then whereas all other chains at the end of the day, when they are trying to maybe consolidate everything together, you see that this thing doesn't make sense. There will be chaos.
Yes, sir.
Yeah, there will be
Yes.
chaos. Yeah, so let's talk about the solution, right? What is that solution? Sorry, I don't know how to do drum roll, or I don't know. Yeah, so the solution is Starknet. Yeah, that's the solution. The solution is Starknet. And yeah, I know most of you, or some of you um, must know of Bitcoin, Ethereum, and then there's now Starknet is also a blockchain, right? And then how is Starknet a solution to all the challenges we've seen? So we'll also see that. So before that, let's even talk about what is Starknet itself. What is Starknet? Now, Starknet is a blockchain, right? That is built on Ethereum. So it is a layer 2 blockchain that is built on Ethereum. So how is it a layer 2 blockchain? Now, Ethereum is a layer 1 blockchain, right? It means Ethereum doesn't depend on any blockchain for anything, right? So Ethereum has the issue of scalability. Ethereum is secured, it is decentralized, but then it has the problem of what scalability. It is slow, and then it is also what expensive, right? Now, Starknet saw this as a problem, and then they came up with a way of actually making sure that transactions are being processed faster, and also thereby reducing your gas fee and all that, right? So they now build Starknet on top of what? Ethereum. And then that's why Starknet is a layer 2 scaling solution built on what? Ethereum. Right. So the what I have here is Starknet is an Ethereum layer 2 scaling solution that uses what? Zero knowledge proof. Right. So it basically uses cryptography, mathematics, and all that. Right. So it uses zero knowledge proofs to be able to prove transactions, thereby enabling what? Faster, cheaper, and then more scalable transactions while inheriting Ethereum's what? Security. Yes, we've established that Ethereum is secure itself. It is also decentralized, but then it lacks scalability. It is very slow. So Starknet saw that, and then they were like, okay, hey, why not let's create a solution to this particular problem? And then the solution they created was to scale what? Ethereum, right? Using ZK, which is zero knowledge. Now, how is Starknet a solution to these challenges we made mention of? You recall we said the challenges is what? Scalability issue, high transaction fee, complexity, and then also bad user experience and all that. So Starknet makes transaction costs what? Lesser, right? They make transaction costs lesser. How did they do that? They bundle transactions together, right? So that they spread the cost across those different transactions, and then they bundle it, do the verification and all that, and then at the end of the day, they settle it on what? The L1, which is the Ethereum, right? And then by doing that, they help you to reduce the gas fee. On Starknet, transaction is as low as $0.01. Sometimes lesser than that. 0.0. In fact, it's even safe to say that transaction is free. Yes, it's safe to say transaction is free. Yeah, so it's lesser. So if you are doing transaction on Starknet, you don't have to worry about, let's say, okay, I want to send $16. I must pay $13. They'll shark. So this is a solution to your problem, right? You pay lesser and then also get the same word value. Your security is also what? Guaranteed, right? The next solution is it enables faster transaction confirmation. So for Peter, yes, you said your transaction had to stay for like 2 days or more. Now, if it was Starknet, I mean, your transaction would have gone there faster, like very fast, right? So the transaction would have been confirmed, and then you wouldn't have to waste much time. Yeah, I think Dell just came back. So Dell I said, Starknet is is a solution to your problem, whereby you send $16 and then $13 was used as gas fee. It was if it was on Starknet, you will have spent $0.01 or less safe for as transaction cost. So you will have had about 12.9 dollars left for you to flex, right? So the next thing, the next problem is, or the next solution rather, sorry, is it maintains security and decentralization. Right. So if you recall, I said Ethereum is secure, it is centralized, but then it lacks scalability, which that is what Starknet is leveraging on. So Starknet is leveraging on the security and decentralization of Ethereum itself, and then with that, it also said that Starknet is also secure and decentralized itself, right? If you trust Ethereum, you definitely have to trust Starknet. If you are heavy on security and decentralization, then Starknet also is heavy on that. Starknet also is secure and then what? Decentralized, right? Now the next thing is the better user experience. I mean, for developers and for users, yes, Starknet has that. A very good user experience. Remember when Sati said sometimes he forgets them, or yes, and all that. But then on Starknet, if you are using wallet like Agent, right, they have social login, social sign in for you, whereby you don't have to bother yourself about those seed phrases, those words, or even your private key that is just a bunch of gibberish that you can't cram, right? Even if you can cram one, you can cram two. Can you cram three private keys? If you cram them, in fact, at the end of the day, you end up mixing them and then you forget. So on Starknet, yes, they have wallets that will help you to experience blockchain easily, right? So you might be interacting with applications, and then it will, in fact, it will seem as though it's a Web2 application, less pop-ups, less wallet pop-ups for you, and all that. Yeah, so these are just few of the solutions that Starknet provides, right? Yeah, so basically we've come to the end of the class, and I would like to ask questions. You guys should ask your questions so that we can basically discuss it together.
So I have a question.
Okay, yeah, shoot.
Blockchain is very popular. Like the most popular application of blockchain is in finance. That's what most people are familiar with.
Yes.
Example, you put your money in the bank and some problem comes up with the bank. Your money is there, but then you know that no matter what happens, whether they rob the bank or not, you will still get your money back.
Okay.
So is there any blockchain now that is secured enough that if there is a hack, I should not be worried? My money is secured. Nothing will happen to my money. Is there any blockchain that has done that?
So you mean if they hack the blockchain or the wallet?
In fact, if for example now I'm using an ERC20 wallet, for example, Ethereum.
Yeah.
So if anything occurs and that wallet is hacked, all the funds present on that particular chain is secured. Like example, let's say they will be returned to the owners.
Yeah.
Is there any blockchain that has guaranteed that?
Yes. It's safe to say yes. And the reason is because believe me when I say that kind of hack is somewhat not how would I even put it safe? It's not like it's not possible. I mean, yes, with quantum computer coming in, but then currently, right? And the reason why I said that is because the blockchain, before they add anything or in fact, before they even thought about the concept of blockchain, the security of blockchain itself is top notch, right? The security is top notch, and the only way I'm coming. Sorry, who is raising up his hand? Okay, yeah, I will call you guys. Let me just finish explaining. So the only way you say a blockchain is hacked completely is when, let's say, for instance, they hack shall I say those applications that basically run the blockchain. So basically, most times there are like two applications: the consensus applications, and then the execution client, the consensus client, and then the execution client, right? So it is the execution client that actually execute those transactions, and then the consensus client actually agree on the transaction, and so on. So except if that application is being hacked, and then how can that application be hacked? Because most times it is open source, everybody can see it. So if anybody makes a little update, right, people will see it. Yes. So for the blockchain to be hacked, then it means the execution client also needs to be hacked. And then it is somewhat impossible, because it is, I mean, the code base is open source. In fact, there are people whose job is to even monitor the code base. Anytime they see anything fishy, they will just come to Twitter or come anywhere and then call out the developers. Hey, why is this like this? Why is this like this? You understand? So there are people who are passionate about the blockchain itself, and thereby their own sole responsibility is to make sure that the blockchain is secured itself. I don't know if that's clear. And then if you are talking about your own wallet being hacked, now let me ask you a question. If, let's say, for instance, you maybe misplace your credit card, right? Or you were careless with your bank details, and then someone uses that to actually siphon money from your bank, will the bank refund you?
No.
Exactly. So the blockchain is secured, but then for your wallet, you also have to be security conscious, right? You also have to make sure that yes, your seed phrase or private keys are what safe. I don't know if that's clear.
Yes.
Yeah. So yeah, your hand was up.
Hello, sir.
Yes, sir.
So I wanted to ask what a zero knowledge proof is, and what is Starknet doing different that Ethereum is not doing that, making it more scalable than Ethereum?
Okay. So zero knowledge proof is just basically a way of you using mathematics to actually prove that yes, this thing is valid without you actually revealing the details of or without you actually revealing that the information of that particular computation. Now let's say, for instance, 1 + 1 is 2, right? And then you want to prove that yes, 1 + 1 is 2 and all that. So first of all, you don't even need to reveal 2 itself. Yes, you don't need to reveal 2. Basically, it's just to do your computation of 1 + 1 and to be sure that yes, this particular computation I did is the same as this output. So I use 1 + 1 here, which basically, it must be 2. But then for mathematics students, there is what they call proving most times, Abi, whereby you are not solving to get an answer. They will give you something with an answer, and then they'll say, okay, yes, prove that this is equal to this, right? Now, you don't know all those steps that were done to actually prove it. So it's the same thing. You pick the equation itself, and then do it till the end, whereby you get the answer, and then you'll be like, okay, yes, this is the same as what? This. So that is just basically zero knowledge proof. Zero knowledge proof is basically what you do mathematics to actually prove that a particular thing, a particular data is what is valid without revealing or not necessarily revealing, but then without having a full knowledge of that. So like I explained with you proving now, whereby they will say that you should prove this formula, right? you don't know the steps that were done to actually get that formula. But then the only thing they gave you is the formula. So you have to prove the formula. You have to break down the formula and then try to be sure that, okay, yes, this particular formula is what is valid. I don't know if you understand.
Yes, I understand.
So what Starknet is doing separately is first things first, they are using zero knowledge, right? Now, with zero knowledge, you don't have to do a whole lot of computation over and over again. Once a particular transaction has been computed, right, you have the hash of that transaction. So what they just basically need to do is to prove that, okay, yes, this hash is also valid. And then with that, transaction confirmation and proving is what? Faster. That's one. And then secondly, they have these concepts of bundling transactions. So for every time, for every one transaction, there's a cost for it. For every one transaction, there's a cost for it. So what Starknet is doing is, instead of all those separate transactions, right, being written directly to Ethereum, what they'll do is that they bundle those transactions and then spread the cost of those transactions across yes, different. So if, let's say, for instance, one transaction is supposed to cost, let's say, for instance, $5, right? Example. Now, what they will do is that they might bundle, like, let's say, for instance, 10 transactions or 20 transactions, and then spread the cost and the cost, which is $5, across all those transactions. So you see that at the end of the day, this particular transaction will have to pay maybe just $0.1. This one will pay maybe $1.15 and all that. So you wouldn't have to pay the $5 yourself. So at the end of the day, they will now join. Okay, this person have brought his own $0.1. This person brought his own. So when they join the money together, you see that it will be up to the transaction cost, right? Now they, on their own end, they will validate that transaction itself, right? Generate a proof for that transaction. Generate a proof that yes, that transaction is valid. And then when they generate that proof, they basically settle it on what? Ethereum itself. They settle the hash of those transactions on Ethereum itself. Thereby, what they are doing is reducing transaction confirmation time, reducing cost for you, and then also making it what secured, while still trying to make sure that yes, your transaction yes, your transaction are not that expensive.
Thank you,
So
sir.
I don't know if that answers your question.
Yes, sir. Thank you.
Yeah, you're welcome. So, Raphael, I think your hand was up the other time. I don't know if I'm mistaken.
Okay, no, I was just trying to let that lady know that your money in the bank is not secure. And you say your money is gone. It depends on how your money is even gone. At times, the bank just bear the losses, right? Even if something happened to your money, they bear the losses, and then it looks as if your money is still there. But sometimes banks experience hacks, and then that money is gone. So they just be the one to refund it. So that's why banks have some stipulated amount of money by the side for such kind of cases, for insurance. So that even if something happens, or the liquid, or the bankrupt, they can pay you your money and everybody is happy.
Yeah. Yes, and I think not just banks. Now, for centralized exchanges like Bybit, during the hack of Bybit, I mean, everybody got his money back. Bybit did not tell people that, okay, sorry, this money that was hacked from this wallet, your own share is inside. No. At the end of the day, everybody got his money. Like, everybody was able to access his money, right? So in that case, that's like the centralized exchange. But then for you having total control of your money, you just have to be sure that yes, you secure things. In fact, there were times that people were complaining in banks that their money just gets missing, and then when you go to the bank, they can't help you. But then if it's on the blockchain, you will see the trace. You will see that, okay, yeah, this money went out as at this particular point in time to from my address to this particular address. So for users whose wallet has been compromised, yes, they do see that transaction also. They will see all the transactions that happen on their wallet and all. And then basically they cannot happen. So in that case, it's just that you just have to keep your own wallet, your seed phrase and private key safe. Yes, any other question? Any other question?
Sir.
Okay.
Sir, is it possible for Starknet to freeze asset?
For what?
Like Starknet to freeze asset in a wallet?
Okay, Starknet to freeze assets.
Yes.
Starknet cannot freeze your assets. Yes, they can't. But it depends on the asset. I think is it USDT? I'm not sure. Yeah, but then I think USDT. When a particular wallet is being reported, they can freeze the asset, right? So in that case, it is the protocol itself that is doing that, or should I say the application itself that is doing that, not the blockchain. The blockchain just basically gives you the tool and environment for you to actually transact. I don't know if that's clear.
Thanks. That's clear.
Yeah. All right. Any other question? Okay, so if there are no other questions, we've come to the end of today's class. Yeah, so what I sent to you guys are some few things. I think yeah, so I will also send I think some few materials for you to actually make research on, or to read. Yes, so that you have more and more understanding on the blockchain itself. Yes, so see you guys in the next class. Cheers.